Now, so here RL series circuit waveforms. RL series circuit waveforms. Voltage and current. Sorry. The voltage, current, and power waveforms of series circuit is as shown in the figure. So here voltage waveform is, so here voltage waveform is given, current waveform is given, voltage is started at 0 degrees onwards, current is started at 5 degrees. Now power waveform is given. So here power waveform is given. So in red color, see here, observe the voltage and current and power waveforms. Here the power flows from the source to the load, and when the power in negative, see in negative cycle, see power flow from load to source. When the power is positive, when the power is positive, power flows from the load to source. So here source to load, the power is positive, it is passed from source to load. If the power is negative, it is flows from load to source. This is the waveform, power waveform as drawn in the diagram. The positive power is not equal to the negative power, and hence the average power in the circuit is not equal to 0. So from the phasor diagram we can write cos phi. Cos phi is nothing but a power factor or cos phi. Here cos phi is nothing but power factor. Power factor is nothing but a cosine angle between the voltage and current. Cos pi is VR by V, that is equal to IR by IZ. So II cancel, that is nothing but R by Z. Here power is equal to VI cos pi. So V is RMS voltage, I is RMS current, cos pi is power factor. So we can write V is equal to I into Z, that is current I, and cos pi is R by Z. We can write power is equal to I square R. So in RL series circuit, the power consumed in the resistance only, but not in the inductance. So power factor is defined as the cosine of the angle between the voltage and current is cos pi. That is power is equal to VI cos pi. The power in AC circuit is equal to the product of voltage and current and power factor. In DC is only V into I. AC is VI cos pi. VI cos pi. Now go for impedance angle. We can derive a triangle called the impedance triangle from the phasor diagram of an RL series circuit. From the RL series circuit. Here we can observe the first triangle is, so VR is the x-axis, VR and I are the in phase. and the voltage across the inductor is 90 degrees leading. So the combination of VR and VL, that means vector addition, here vector addition VR and VL, which gives the V. So VR VL is which gives the V. So VR we can write in this way: VR is equal to I into R. So VL is equal to I into XL, V is equal to I into Z. So in all the combinations, I is common, so we can write. So x-axis is R, y-axis is XL, and these two resultant is Z impedance. So the impedance triangle is right angle triangle with R and XL. As two sides and impedance as a hypotenuse. The angle between the base and hypotenuse is pi. That means here the voltage and current phase angle is pi. That means base is nothing but x-axis. That means R, VR or I, and the hypotenuse means here V or IZ or Z. So between these Z and R or V and VR or V and I, the phase angle is pi. So the impedance triangle enables us to calculate the following things. Those are the voltage or current, whatever the impedance. Now, so first one is impedance. Z is equal to under root of R square plus XL square. So that is the impedance calculations. So R is the resistance, XL is the reactance. Now another thing, the power factor. Power factor means the cosine angle between the voltage and current, means cos pi. So cos pi is equal to R by Z. R is the resistance, Z is impedance. That is the power factor. Here in power factor, from this power factor we can calculate the phase angle. So pi is equal to, in the second power factor, from the cos pi we can calculate the pi also. Pi is equal to cos inverse of R by Z, that is the phase angle. This is the another method we can calculate. So cos pi is equal to R by Z, pi is equal to cos inverse R by Z. That is the phase angle, this one is the power factor. Now in another method, the phase angle pi is equal to tan inverse XL by R. So tan inverse XL by R. So now whether here the current is a current leading or lagging behind the voltage here. If it is inductor, current is lagging. If it is capacitor, current is leading behind the voltage. Power. So in power, how can we calculate the power in AC circuits? The various powers are classified in AC circuits. So that means here real or active power or useful power. That means, for example, we consider, say, a fan is rotating, a fan having the winding and with supply, and it is a mechanical rotating parts. When we are given to the supply to the fan, it is rotating. So here here rotating means which gives the power. That means active power is called active power or useful power. So next one is reactive power. Reactive power means where the inductance or capacitance is present. So here inductor having power, that power is called reactive power. Capacitance having the power, that power is called reactive power. The capacitor or inductor does not have the active power, only it has reactive power. Apparent power is nothing but a combination of active and reactive power is called apparent power. That means it is combination is nothing but a not a algebraic sum, it is a vector sum. So here real and active power in AC circuit is the power that does useful work in the circuit. Reactive power flows from an AC circuit but does not do any useful work. So apparent power is the total power in AC circuit, that means active and reactive. So here x-axis is I cos pi and y-axis I sin pi, and these resultants I cos pi and V are both are in phase. I cos pi I sin pi resultant is nothing but a I. So the phase angle is pi. So the resultant of I sin pi and I cos pi which gives the I. So here the pi is nothing but the voltage and current between the phase angle voltage and current phase angle. So now from the phasor diagram of an RL series circuit, current can be divided into two components. One is the I cos pi along with the voltage, that is called active component of current. Another one is component perpendicular to the voltage I sin pi, that is called reactive component of current. So now go for real power. So real power, the power due to the active component of current is called active power or real pi, I cos pi. That means Vi cos pi, power is equal to Vi cos pi, that is equal to I square R. So real power is the power that does useful power. It is a power that is consumed by the resistance. The unit of real power is in watts. So now reactive power, the power due to the reactive component of current, that means I sin pi. So reactive component of current I sin pi. So that is denoted by the reactive power denoted by the Q. Active power denoted by the P, units are watts. Reactive power denoted by the Q. So that units are react units are VAR. So that is Q is equal to VI sin pi, that means I square XL or I square XC. So here it is a circulating power in the L and C components. The unit of reactive power is volt ampere reactive, it is VAR. So now apparent power. The apparent power is the total power in the circuit. It is denoted by S. So S is nothing but V into I. So that is I square into Z. So S is equal to, it is the vector sum of active and reactive power. Active power is P and the reactive power is Q. So S is equal to P square plus Q square. The units of apparent power is volt amperes. So here the power transformer units are kVA, volt ampere, kilovolts ampere. Example, the power transformer, so units are kVA, kilovolts ampere. power triangle. So from the impedance triangle, another triangle is called the power triangle that can be derived as shown in figure. Now we already seen this one. So here Z or X, R is the x-axis, X is the y-axis, and R and X combination. That means vector combination which gives the Z. Here both sides multiply with the all sides I square Z, I square X, I square R. I square R is nothing but a active power. I square XL is nothing but a reactive power. I square Z is nothing but a apparent power. So here PQS, S is equal to under root of P square plus Q square. This is the power triangle. So now P and Q two sides and S is the hypotenuse. So the angle between the base and hypotenuse is pi, and the power enables to use to calculate. It is enable us to calculate the following things. So what does the following things? Apparent power S is equal to under root of P square plus Q square. S is nothing but apparent power, total circuit power, combination of active and reactive power. Power factor. Power factor is nothing but cos pi. That means P by S, real power divided by apparent power. So cos pi we can calculate in other way, that is VR by V or R by Z or by Z in previous equations. So now the power factor in any AC circuit can be calculated by any one of the following methods. So power factor. So cosine of angle between voltage and current, resistance, cos pi is equal to resistance by impedance or real power by apparent power. So now phasor algebra in all series circuit. Here phasor algebra. That means here the supply voltage is V is written as V plus J0. That means V angle of 0 degrees. So now impedance, that is a Z bar is nothing but a vector. Phasor Z bar is nothing but Z phasor. Z bar R plus JXL. So R plus JXL is rectangular form. Now convert into polar form. Z angle of pi is the polar form. Now current is I is equal to V by Z. So V by Z, Z is nothing but a Z bar here. Z bar is nothing but a phasor that can be written as Z into angle of pi. So in denominator angle pi, so when it goes to the numerator, it is minus pi. So now S bar is equal to, we can write S is equal to Vi star. So here this is written in this star, it means Vi star notation. So that is P plus JQ. S bar is nothing but P plus JQ. Here see one problem in this case, how can we calculate? So how can we calculate the current, phase angle, power factor and power consumed? So we see this one. So here, so coil having resistance R is given 7 ohms and the inductance is given 31.8 millihenries. Here L is given but not XL. So we have to determine the XL. XL is equal to 2 pi FL. So only L is given. So XL is equal to 2 pi FL. L is substitute, we can get the XL value. And that means inductive reactance. So connected to 230 volts. That means here the RMS value of voltage 230 volts and frequency is 50 Hz supply. Calculate the circuit current I and the phase angle, power factor and power consumed. Now, so here first we have to calculate the XL. So why should go for XL? When we determine the current, we have to know the impedance and the XL. If you know the impedance and XL, we can calculate the current. So now XL is equal to 2 pi FL, 2 into 3.14, that is 50 into 31.8 into 10 to the power of minus 3. So XL is 10 ohms. XL is 10 ohms. So now Z is equal to, here impedance, the R and XL is the vector sum but not the algebraic sum. So under root of R square plus XL square, R is the 7 ohms and XL is 10 ohms. So under root of 7 square plus 10 square, which gives the 12.2. Now current is nothing but I is equal to V by Z. In generally, many members are writing I is equal to V by R. That is the wrong. So we can write V by Z only, not V by R. V is the supply voltage. V is the supply voltage, not the resistance drop voltage. So total supply voltage divided by impedance, which gives the current. So some members are doing the mistakes in exams. So I is equal to V by R. That is the wrong in RLC series circuit case. Only V by Z. 230 by 12.2, which gives a 18.85 amps. Now, so in second case, so phase angle we can calculate in any different way. Pi is equal to tan inverse of XL by R. So XL is how much? Here 10, R is the 7. So 10 by 7 is 50. So tan inverse of 10 by 7 is nothing but 55 degrees. Here this is the RL circuit. So resistance and inductive circuits, so it is lagging by 50 degrees. The current is lagging 55 degrees. So now power factor is, so power factor is cos pi. Pi is already, so we determined pi is 55 degrees, so cos 55 is 0.573 lagging power factor. So now power consumed by the circuit, power absorbed by the circuit is P is equal to VI cos pi. Now 230 into, so P is equal to VI cos pi, 230 into 18.85 into 0.573, that is equal to 484.24 watts. Now another problem we have to do the problem, another problem. So here, so what is the given? Supply voltage is 200 voltage supply is given. So now 50 hertz inductive circuit taken as a current of 10 amps. In previous case problem, the current is not given. We determine the current. So here lagging 30 degrees is also given in previous case problem. So he didn't given the angle. So he has given in previous case resistance and inductance value. So but here the different case. So what here asking, so first one is the resistance and second one is the reactance and the third one is the inductance of the coil. So here voltage and current is given, so we can get the impedance directly. So Z is equal to, what is that? V by I. So V is the supply voltage 200 and I is the current 10 amps, that is equal to, so 200 by 10, that means 20 ohms. What is the 20 ohms? What is that? Impedance. That is impedance. Now first, so resistance formula, R is equal to Z into cos pi. In generally, we can write the cos pi is equal to R by Z. From that equation, we get the R is equal to Z cos pi. So Z already we determined, so 20 ohms, and the given cos pi is given 30 degrees lagging. So R is equal to Z into cos pi. That is nothing but 20 into cos 30. Cos 30 is so something value. So with 20 into cos 30 we get the 7.32 ohms. That is the resistance. It is in ohms. Now go for the inductive reactance. That means XL. Second one is XL, inductive reactance. XL is equal to Z into sin pi. XL is Z into sin pi. R is Z into cos pi. Here the different. So R is Z into cos pi. When we are calculating the R value, R is equal to Z into cos pi. If you want to calculate the XL value, that is Z into sin pi. Here XL is sin pi, R is cos pi. So that is 20 into sin 30, which gives the 10 ohms. XL is 10 ohms. Here Z is the 20 ohms, R is the 17.32 ohms, and XL is the 10 ohms. So we have to determine the last one is, that is the inductance of the coil. In general, what is the inductance of the coil formula? XL is equal to 2 pi FL. XL is equal to 2 pi FL. From this equation, so we can write L is equal to XL by 2 pi F. So XL is 10 ohms and 2 pi F is 2 into 3.14 into 50. That is 0.0318 Henries. 0.0318 Henries. That is the, so values are calculated, those calculated. So here resistance, inductive reactance and inductance we determined. So this is the case we have determined.